Good afternoon, everyone. I'm Sandra Erwin, Senior Staff Writer at Space News. Welcome to today's panel discussion on the Golden Dome Missile Defense Program that has become one of the most closely watched initiatives in national security, not just in the traditional defense industry, but also across the space industry, the tech sector, and of course, AI. As we heard last week from the top DoD official in charge of Golden Dome, General Mike Gutlein, the Pentagon is moving forward to develop and deploy a layered defense against hypersonic and ballistic missiles and aerial threats. They are on a 60-day deadline to come up with an objective architecture that would include a mix of existing and yet to be developed missile defense systems on the ground, at sea, in the air, and in space, and the data architectures that tie them all together. One of the key topics we'll explore today is the backbone of the system: data, AI, network integration, and command and control. We will unpack where things stand, what's coming next, and how companies are aligning their capabilities in anticipation of Golden Dome acquisition opportunities. If you have questions for our panelists, go ahead and submit them at any time. We will get to Q&A near the end of the hour. Also, this event is being recorded and a replay will be posted later today. Before we jump into the discussion, I want to thank our event sponsor, Amentum, for supporting today's panel. We'll now roll a short video and then we will get started.
Our world faces intense challenges and immense possibilities. At Amentum, we believe in a secure, vibrant future, but achieving it requires protecting our people, resources, and planet. For over a century, we've tackled pressing issues with historical significance. Yet we remain focused on what's next, advancing initiatives that clean our environment, support our nation and our allies, and explore our universe. We're delivering advanced engineering and technology solutions to address the most significant challenges in science, security, and sustainability. Our mission is clear, and our time is now. Amentum, advancing the future together.
Okay, so now I would like to introduce our panel of distinguished experts who will be talking about Golden Dome. First, we have Rob Mitrevsky, President of Golden Dome Strategy and Integration at L3Harris Technologies, Patrick Bilchen, Vice President of Space AI at Booz Allen Hamilton, and Dan Knight, Vice President of Sensors and Data Integration at Orion Space Solutions under Arkfield Corporation. So welcome, Rob, Pat, and Dan. Thank you for joining us. And I guess before we dive into the Golden Dome specifics, maybe I would like to have you all talk about your backgrounds. Rob, I'd like to start with you. I'm interested to hear a little bit more about your new role overseeing how L3Harris ties together these moving parts of Golden Dome. I mean, the company created a new position. Can you maybe share what you're doing and why the company is going in that direction?
Sure, Sandra, and thanks for having us. We really appreciate being on the panel. Look, I think, it's a great honor for me to be named to the position. Obviously, I'm very excited to do so. L3Harris has a significant amount of capability in its broad portfolio to represent well in the capabilities required under the Golden Dome executive order. If you read through the executive order, we obviously have a number of line items which talk about quite a few capabilities, ranging from the things that I call shovel ready, the one that says accelerate HBTSS, which has been a great success for us, but also ranging through space-based interceptors, non-kinetics, custody layer, lots of other things. And then what's unsaid in there too is what General Gutlein has talked about more recently, which is the command and control, the C2 part of the architecture, which in my opinion is certainly the most complex part of it. And I think the role was created primarily because there are a lot of pieces that industry is going to be participating in. We need to be unified, not only within the company, but within the industry with the Direct Reporting Program Manager's Office, General Gutlein. This is a way to create that unity within our company to make sure that our capabilities are represented well, but we also represent primarily the needs of our customer back to us so that we can best align what we can do best with what the nation needs. So I think this is why this role was created. I'm happy to do it. We've had success in my prior role at aligning with this evolving threat to our nation. And certainly we're prepared for it with unity and with urgency. So thanks again.
Thank you. So Pat, can you maybe tell us a little bit about your background? I know a lot of people in the AI sector know about you, but many people may not know who you are. And talk a little bit about why Booz Allen, known as a technology advisor and consulting firm, why they decided to get involved in Golden Dome?
Sandra, thank you. So, let me just echo what was said about thanks for being on the panel, and thanks to Space News for leaning forward in your coverage of Golden Dome. Obviously, this is an opportunity that's of interest to the whole of industry, and we're all going to need to be part of it if this effort is going to be successful and deliver a solution rapidly. I did my PhD at Georgia Tech, applying AI to modeling and simulation of systems for the Air Force in 2008. And after that, pretty much nobody was interested in that. It was kind of like, that was kind of an interesting problem, but AI isn't a thing. So I worked data integration and sense-making programs for the IC over the last 20 years. But in the last couple, this AI thing has become a thing. So what I've been working is the development of models, integrated systems, and then applying some of these new AI techniques to sense-making and analytic systems that can also be used for battle management and command and control. Although Booz Allen has been traditionally known as a consulting firm, you've seen us take a turn recently as a technology integrator. And we have a lot of capabilities across our broad portfolio that include the development of AI models, large-scale ground software engineering and systems integration. And then for something like Golden Dome, there's going to need to be a tight integration from concept development and modeling and simulation, which is a lot of our heritage capabilities, all the way through integration and implementation. So that's one reason why Booz Allen is excited about this opportunity. And we have a highly technical staff that has a lot of great credentials across DoD, IC, and civil programs that we're going to bring to bear with partners, including some of the people on this call. Thank you.
Thank you. So Dan, same, would like to maybe have you talk a little bit about what you do and Arkfield's role in the Golden Dome program.
Yeah, again, let me echo what the two previous gentlemen said. It's an honor to be on here, and it's a great opportunity for us to kind of continue to mature the thinking with regard to Golden Dome in a cross company, cross sector type situation. So excited for this. My role from a day-to-day Orion is sensors and platform engineering. Orion Space. We deliver primarily small satellites. We're up to an ESPA class now. We are on the Tetra program. We're delivering a VLEO satellite. I am focused on both space and ground-based sensors, optical and RF regimes for a variety of functions. And then we model the space environment. So we think all of those from a pure capability perspective are very interesting. My other job is to lead the overall Arkfield effort in the Golden Dome for America campaign. And so we have 4 sectors. So model-based systems engineering, intelligent model-based systems engineering out of our STC sector. They have done a lot of work that really enhances the ability to scale, which is going to be essential for Golden Dome, building on legacy systems and delivering new systems and bringing them all together. Just today, we talked, I think it was General Purdy that talked about, the important area is the gray space between systems, not necessarily the systems. And so we bring that also with our space and mission engineering that's done a lot of work in the Title 50 world for many years, doing system of system integration and models MS&A. So we have a lot of experience, which we think will be very essential there. And then we also understand that, in our perspective, Golden Dome is going to be about, it's going to be a large defense of North America, but there's also going to be tactically forward units, and delivering that data to the tactically forward units that may not have the higher classification systems is going to be important. And so when we think through how we deliver data, how we manage it, what environments we bring it into, it's going to be important to set up an architecture that is can be enabled by cross-domain solutions. So we're very excited and look forward to participating.
Great. Thank you, Dan. So with all that, I guess I wanted to maybe get a little bit into this objective architecture that General Goodline mentioned. I guess maybe Rob, can you, or maybe all of you can weigh in on this, but I'll start with Rob. What is an objective architecture? What do you think that we're going to see after 60 days?
Well, I think what I'll start with is General Goodline told us last week, if you think you know what the architecture is, you don't, because we're still sort of working it out. So I don't think I'm going to presuppose based on that that warning exactly what it is. But again, the executive order, I think, tells us a lot about what they have in mind. It obviously a multi-layered architecture. They call it a national defense shield, but as Dan just said, it's really about the homeland, but also in theater. It's about different phases of flight, right? It's sort of pre-launch, left of launch, right of launch, and boost phase, mid-course terminal. It's protecting military and civilian targets. It's ground, air, and space. So there is a significant scope that is being asked for as part of this executive order, and therefore the architecture will be complex, multi-layered. It'll be, I expect a lot in space, obviously, because that's what it lends itself to in terms of those 8 implementation priorities. But it's not just space, as I said. I think, again, the key is, how do you drive real-time, high-throughput data to decision-making at a latency that's required to protect our homeland and our allies from hypersonic glide vehicles, which are evolving threats, from conventional and non-conventional weapons, from advanced ground, air, and space attacks. So it is a significant undertaking, which is why I think it'll take the entirety of our industrial capability working in close hand with the Department of Defense to get this done. Hopefully we'll get incremental insight into those architectures as we go through industry days and as General Goodline and his staff talk to the industry between now and that 60-day period. We expect incrementally to see that 30-day report out, which is more about organizational structure and about authorities. But, hopefully we'll see increments of data as we approach that 60 days.
Got it. So, Pat, what about you? What would you like to see in this architecture plan, or what do you expect that we're going to see in this objective architecture? And maybe talk about, the integration aspect of it, and how would that be explained in this initial plan?
Well, Sandra, we have heard that Golden Dome will be a mix of some existing systems and some new systems. I don't think that you can just assert the stuff that we have will solve the problem, because I think we know that's not true. So there is a gap analysis that says, here are some key areas where we need new systems or perhaps multiple redundant systems to address the challenge. We know, for example, boost phase intercept is probably the best phase of flight to intercept these weapons soon after their launch, before they can do anything sneaky to avoid detection or interception. So that's a component that's always been hard since the beginning of rocketry. I think we'll see a desire to have capabilities in that phase. I think we're going to see a focus on ground-based and space-based interceptors, because that's what you'll need to get a comprehensive solution. But I also don't think we're going to see a complete architecture. I hope that the government is not going to prescribe, this is what we think the answer is in a 60-day effort. Usually it takes 60 months or 60 years to come up with a very comprehensive architecture, and there's just not time to do it like that. So I'm hoping that General Gutlein and his team come in and say, here are some things we know, here are some things we don't know, but we're leaving the design space open for some creative solutions. Now, when it comes to integration, if it is a mix of existing systems and new systems, it will be very hard to prescribe data and integration standards and demand that everyone integrate with them and make changes to their systems. So that's an opportunity for AI-enabled integration. And I know that sounds like a buzzword, but a lot of these advanced models are capable of doing data translation and almost in some cases writing their own services to interoperate. That would have sounded insane if I even suggested that 3 or 4 years ago, but those are real capabilities that we're seeing right now for automated code generation, automated testing of integration of systems. And so I do think there will be a component of relying on those new technologies for integration. The last point that I'll make is I expect that the magic will be in the software. We usually get obsessed with the hardware and we say, I need X many of these things and Y many of these things. And there is a lot of bending of metal and creation of sensors and integration and launch that's required. But software is the way that you teach old sensors new tricks. And I suspect that we will see calls for innovative approaches that combine traditional, non-traditional, and commercial software together into a hybrid architecture. And that integration is going to be, I think, the biggest challenge.
Let me just follow up. Booz Allen proposed a space-based architecture, the brilliant swarms. And my understanding is that it would be compatible with the existing, with the legacy systems. I mean, with all the simulations and advanced modeling that you guys do, do you actually believe that can be done?
I think it's going to be hard, but it also has to be simplified. So one of the key aspects of brilliant swarms, okay, this is an homage to the original brilliant pebbles concept from the Strategic Defense Initiative, except that almost everything about that problem has evolved over the last 40 years. So things that we used to say are impossible or violate the laws of physics now are very close to violating the laws of physics. You can solve a lot of those problems that we thought were unsolvable. So what I mean by simplifying the problem is like, don't write 1,000-line data ontology that you have to validate for every system. Just say like, it's X, Y, Z, T, look over here. So we're gonna have to think of innovative ways of doing off-board tip queuing, self-queuing, onboard processing. And I think if we try to say, how can I solve this problem as simply as possible, instead of as perfectly as possible? And by the way, that's really hard for a lot of us. I mean, some of the people on this call, we're all really good at making really good, amazing, exquisite solutions. But if we're going to meet the president's timeline for deploying this, we have to think about, how would I get this data to these systems with the minimum number of modifications as quickly as possible? And if you frame the problem as a time problem, then you start to come up with different solutions. So I do think we have confidence in the ability to deploy that type of system as evidence in our brilliant swarms concept, but it's going to rely a lot on taking those lessons learned and saying, how do you deploy a system with a baseline capability as quickly as possible that can evolve over time? And you hear the term modern open systems architecture, or MOSA. I think all of us have that mindset in place. And that's going to be the key to saying, I'm going to get you something with an initial capability that can meet the requirements and then evolve it over time, instead of trying to spoil the entire ocean with the first deployment.
Mm-hmm. That's a good point. So I guess I wanted to follow up with another question for Dan. I guess, given what Pat just said about these data challenges, how how do you think DoD is going to work through the, you mentioned earlier, there's going to be there's a national missile defense, and then there's a tactical component, and all that has to be integrated. There's different levels of security. How is DoD going to work through the data ownership, trustworthiness, quality of data, and when you have government and commercial, what are some of your thoughts on how DoD can address that problem, Dan?
No, I think that's a great question. And, we spent a lot of time talking about that this weekend and today at this conference. It's a data problem, as I think Patrick and Rob both either talked to or alluded to. It's not necessarily a hardware and bending metal problem. And that in many cases, we have the information or we have the data that we need. It's just not in the right places. And so going forward, I think it's going to be essential for us to, one, architect what is currently in place through model-based systems engineering, and then build out on that going forward so that we have, data streams and formats that are integrated and can be moved to the right places. I can't speak to how we're going to work through data ownership. That's a tough challenge. I think a start is to, understand what we're dealing with and figure out from an open architecture, as Patrick said, how we're going to integrate those things. And, ideally, General Gutlein will have the mandate, and he will get the support from both the services and some of the C2 decision makers that are going to make this, from missile defense, from NC3, from ITWA, that they will all start to collaborate and collude and share that data across, multiple formats and multiple streams. So I think that's going to be key. And then again, in order to get it to the tactical warfighter, we're going to have data environments where we can really leverage cross-domain type capabilities to deliver, and so that we don't suck up all the data into a TS environment and then only the national command centers can access it because we don't have the ability to get it down to the lowest level decision maker. And so that's definitely going to be a challenge, but I think that's very much on the forefront of the thinking. And I don't think, as Rob said, this is just going to be a defense of North America, because the first time that in an overseas location we confront a situation when we're dealing with everything from drones to medium or short range ballistic missiles, a system like this is going to be needed, and that infrastructure that's in place is going to have to adapt to it.
And of course,
Sandra, can we pull the thread on that real quick? Because I think this is an important point for all of us here on Golden Dome. So in our discussion here, Dan, as you just noted, there is still some discussion about, and it has to go to the tactical warfighter. So this is a place where I think the government needs to be clear. And what I'd like to see at an industry day is, what is the point of Golden Dome? Is it to protect the homeland? Or is it to provide tactical capabilities? Or does it also do hypersonics over the ocean? And so, but that really influences the requirements. If it needs to solve all requirements, like we define our embassies as the homeland, therefore it must protect every US interest globally, that's different than it has to protect the US or the continental US. And so all of those things will dramatically influence the complexity of the solution. And I think the government should have a layered approach to how this is deployed, to avoid everyone going, hey, Golden Dome should also do this, and it should do this, and while it's there, it could also do this. Because we as providers get really excited about additional requirements. I think the government needs to bound the problem into what they believe Golden Dome needs to do.
Yeah, that is a really good point, because I think General Gutlein, when he gave that talk last week, he kept talking about C2 this, C2 that. I mean, it was command and control. And it sounded like he was talking about global assets or globally connecting assets. But again, we don't know the requirements, as you pointed out. And then we get into this one of the big headlines of Golden Dome, which is defending from hypersonic missiles. And I guess that's where we see space coming in as a critical component. So, Rob, you mentioned in your introductory comments HBTSS, which a lot of people are familiar with, other people may not be. It's a system of satellites. L3Harris deployed a prototype satellite to track hypersonic missiles. So I'd like to maybe get you to talk about what that HBTSS system has accomplished so far. Can it detect hypersonic, like what Pat said, hypersonics over the ocean? And what is your vision on how they would be able to integrate HBTSS into perhaps the whole ground and sea and air architecture?
Sure, Sandra, I can. I'll steer clear of what I'm not allowed to say. I can say that, MDA's view is that the HBTSS prototype has met its objective, its mission objectives on orbit. We're very pleased with where it's gone. It was designed to be a fire control asset from space, right? With the advent of hypersonic glide vehicles, you no longer have these clear, predictable ballistic trajectories where you can use ground-based radars to create fire control capabilities and messages to the interceptor, because the hypersonic glide vehicles are not only fast, which everybody focuses on, but more importantly, they're dim and maneuverable, and they create a very difficult scenario for us in our national defense. Doing that mission from space in a way that's persistent with global access is the way to do it. And the HBTSS prototype has demonstrated that that is possible. That's another thing, Patrick talked about the difference from SDI in the 80s, right? Our current state of technology has made it possible to do this, and it's not only in the sensing, but it's in the onboard processing, it's in the algorithms, the advanced algorithms that are on board, et cetera. So HBTSS will be, in my opinion, the linchpin, the very important piece of this architecture in the way it can inform an interceptor or in real world cases. If you look at what's going on in the Middle East and Russia and Ukraine, et cetera, a number of interceptors were to go, right? And where to go with the accuracy and the latency and the timelines that are required to protect critical assets. So I'm very pleased with our readiness on HBTSS. It's not just a demonstration of capability, but it turns into things that are in the EO, also resilient supply chain, a capability that's shovel ready, as I like to call it, that we're ready to deploy if we had the word. So, going back to your original question, what would we like to hear is a prioritization of what can be done now versus what needs to be done incrementally, as Patrick talked about. Some things can be done immediately, right? There's one thing that says accelerate rather than develop and deploy, and it happens to be the thing I like to talk about. But I think we need some priority and some implementation of that priority. And for us, I think that's really critical because it is a very complex system, as we've all talked about. And the things that are ready and easy should be done, because we do need to focus on the things that are difficult. The C2, the way the glue logic in connecting all these disparate pieces is really going to be the hard part. I am certain that that's why General Gutlein has been focusing on it over the last few weeks, is because there's a realization of the difficulty of taking existing systems or near existing systems and ground systems too. Let's not talk just about hardware, but ground systems that exist sort of all over the our capabilities. C2BMC from MDA, IBCS, CEC. There's some NATO systems that either need to be glued together to work together, or we need to sort of think through how we're going to do that command and control. So I think HBTSS is very directly important to us. It's important to the architecture. It's a near-term sort of quick win if that's what General Gutlein and his team want. And yet there are other things that we also need to focus on to make it all work together, because it by itself isn't going to get us completely there.
To Pat's point, he made a few minutes ago that Golden Dome is a national missile defense, and we don't know, what about all the other areas of the world? But when you talk about hypersonic missiles, can you explain why you have to have a global system? Because a hypersonic glide vehicle or hypersonic missile could be anywhere in the globe, and if it's threatening the United States, you would have to be able to see it anywhere in the world. So how many HBTSS satellites would you need to do that?
I guess it depends on exactly what you want to accomplish. I think the architecture that was provided by the Missile Defense Agency immediately is, if you want to protect the homeland and the mid-latitudes, you need about 40 to 45. If you want to protect the entirety of the globe, including the poles, and have persistence over the poles, then you need about double that. That makes some assumptions of altitude and stereo coverage takes those into account. And you need a global access. It's for the reasons we cited before, which is fast, maneuverable, dim. We've seen China do the fractional orbital bombardment system, 4 years ago, where they had a fractional orbit on a hyperglide vehicle. So we know that there can be some things parked in orbit, while there can be some things endo-atmospherically also that are launched at with our homeland as a target. So a global system with stereo coverage is really what you want. And so that architecture goes from there, right? And it's physics at that point. And depending on what sort of coverage you want will dictate the number of assets you need.
Understood. So I guess maybe this would be more a question more for Dan. When you think about HBTSS, and then you also have the Space Development Agency tracking layer with low Earth orbit satellites. When you look at all that data from space, and then you look at the data from the ground and from aerial assets and whatnot, what are your thoughts on a strategy for leveraging all those sensors and be able to have an integrated picture? And how would AI and machine learning be used for that? Is that something that does DoD have the tools to do that, or does industry have to come up with new tools?
So I would say, do they have the tools? So one, I think that's a great question. And I'll try to keep it short, but I could probably talk for hours about that question right there, like probably the other individuals here. Bottom line is, are the tools available? Yes. Is the maturity in our ability to apply those tools to a large data set and get the results that we want, have we done that successfully and repetitively? I would say no, but I think it is very much on the forefront of all of the different C2 centers, because you really have operator task overload. You have an enormous amount of data for people to sort through, and using AI, and then particularly machine learning and large language models to train on that data to help queue and ensure, provide a safety net for those operators that are in many cases manually viewing that data in a format that they've dictated. It's ineffective. And so I think as we deploy a variety of sensors, HBTSS, ground-based sensors, airborne and other space-based sensors, fusing all that data and then using AI really to ingest and take in those artifacts, and then process it against some large language models that have been trained on that, is going to be essential. Otherwise, we're going to have large data sets that we only use 10% of, and there are going to be things that slip through the cracks. So I'll stop there on that. I did want to go back to the thing I said before And I don't think that Golden Dome will be the be all end all, but I also think that the way we design the architecture and, you know, the digital engineering is going to be key, so that we build it so that as national priorities change, as leadership change, as something goes boom in the world somewhere, and that the DoD or our national leaders decide to pivot, that we will have the ability to take the work that we've done and pivot against that. And I think digital engineering is going to be key to putting ourselves in the position to be successful. So I'll stop there.
Okay. So I guess the maybe a follow-on question for Pat here on AI and data and all these thoughts about how DoD can make this seamless command and control. We've heard from some commercial companies, you know, Palantir, Shield AI, there's a lot of, you know, interest in bringing commercial innovation into Golden Dome. What are your thoughts about the models that are needed to do this? Does the industry have advanced models that can be used? And how would they be trained? And how would they assure the government that these are trustworthy models? What would be the process to do that? It seems like it would be really complicated to do that on the timeline that DoD wants to get this deployed in 3 years. But what are your thoughts on that?
So, Sandra, that is a complex question, and I think a concern that's sort of being overlooked. There's a lot of discussion about commercial companies that have spent hundreds of millions or billions of dollars creating a model that's a general purpose model. In the case of Golden Dome, so in a lot of government systems, sometimes when we talk about it, we say, oh, I'm using the Meta Llama model because it's open source and it's open weights and it's well understood. And on computer vision, there's a model called YOLO that's an open source model that many people use for object detection. If you're going to use that for Golden Dome, you don't want the adversary to know that's your model, because they can say, if we know that's your model, we can try to figure out how we would deceive it or break it. So one of the areas that's complex and potentially very expensive is the government may need to train their own unique secret models that are not known to the adversary. To remember, Golden Dome is all about ambiguity. Are the interceptors and sensors in the right place where they can actually intercept? And if you give the adversary enough ambiguity about their success, then they can't attack you. So you can't build the whole system and then say, by the way, this is the model and the weights I was using. So that's one area that's important. The second thing is, within the DoD community, there are people that know about AI. That's true. We may not have the volume of personnel with the right skill set to do what I just said. And so that is a gap in the workforce. And you've got, you know, Mark Zuckerberg, I think, gave someone like $100 trillion to come work for him. But like, that's more than the whole budget of Golden Dome to get one employee. So how are we going to do that? And then the last part that I think is important is many AI approaches begin with, I'm going to label some data and train a model. But there are no examples of World War III starting that can be labeled. So, you know, going back to the point mentioned by Dan about modeling and simulation and the model-based system engineering, we're going to have to build a digital twin of Golden Dome and run it in simulation space, doing reinforcement learning and self-play for the equivalent of 100 billion years. And you're going to have to run every possibility. Like Rob said, there's all these weird cases for hypersonics. You're going to have to feed those in there and say, what would the system do? And that's how we're going to be able to do verification and validation for an event that's never happened before. Now, if we do that with confidence, it also increases the ambiguity for the adversary. They will not know how well we validated the system because it will all happen in a very secret simulation environment where only a handful of people are going to know how it actually performs. That's going to be one of the keys to success, is we're not going to talk a lot about how well it does at each function in that MBSE model. We're going to need to keep that a secret so that the adversary really has no idea how well the system works.
When you talk about this type of use of AI for interceptors, we heard from Booz Allen that you all modeled brilliant swarms so that you would have a smart AI swarm, that they would know exactly what interceptor you would have to launch to hit XYZ target. Would you be able to apply that to ground interceptors or naval interceptors, perhaps, or is that even doable?
So I think so. I mean, there is going to need to be a very rapid decision-making approach. So one particular caveat is like some people are really weirded out by the idea that these interceptors might be AI enabled. Like you're going to have these angry space robots that are just going to chase things and intercept them. Well, with the exception of the International Space Station and the Chinese space station, there are no people in space. So if you blow up someone's climate satellite, you're like, whoops, I guess I'll buy you another one. Sorry about that. But when we talk ground-based interceptors and sea-based interceptors, we know from accidental shootdowns that there are a lot of civilian vehicles and other, there are people that are going to be in this global battle space. So while the algorithms could be applied, I'm a big proponent of a human out of the loop system in certain cases, but a lot of people disagree with me. They say we always need a human in the loop or on the loop. I just don't think you're going to have comms and you're going to have time. But that applies to an environment where people will not be harmed. When we take it to ground-based and sea-based intercepting, that doctrine may need to change. Pat's view of that, the controversial view of that, may need to change because we then have a different threshold on the value of human life as people are moving through this battle space.
Mm-hmm. Mm-hmm.
I do think it's important, Sandra, that we've moved from sort of the modeling and sim discussion to the decision support discussion in real operations, right? I think the use of AI there, as Pat said, will be very important based on what we understand will be the nature of an attack. If you look at some of the missile raids that we've seen in actual conflict over the last number of months and few years, you'll know that the decision support will be of utmost importance, and AI is a very, very strong application of that, particularly in trying to prioritize which targets with which interceptors at which sequence of events need to happen in a very, very short time frame. And when you're talking hypersonics, it becomes increasingly important because of the lower latency, right? Drones are slow and intercontinental ballistic missiles are fast, but hypersonics in their trajectory are very difficult targets. And so AI support will be very important, and we'll need to get through that discussion about humans on the loop or in the loop, as Pat says, in due time, but certainly a great application of it there.
I guess I would.
Yeah.
No, I was just going to say, I think the speed of the game is what is going to drive the comfort level with regards to AI-enabled engagement. Because as we've seen with some of, I think we've all seen on TV some of the Ukraine attacks, Russian attacks in Israel, where you have drones, medium-range ballistic missiles. We haven't seen hypersonics necessarily, but you have a combination in large scale and in large numbers. The ability for a human only decision matrix to execute at the speed of operational relevance is quickly diminishing, and that AI is going to be that solution. So perhaps we need to posture ourselves with how we think about things and build that architecture now, so that when the speed of the game surpasses, the ability for a human to do that resource allocation and kinematics in order for the optimum engagement, that we can then enable AI and kind of phase into that.
And by the way, Sandra, 5 years ago, nobody was saying that at all. Yeah. That sentence, Dan, that you just said, every single public speech was always, and there will always be a human in the loop whenever there's a blah, blah, blah. And now, Dan, you're right. It's the speed of the game is driving the requirement. We're going to have to do verification and validation to trust that there is a full auto mode under certain circumstances, because the human is the weak point in the loop, right?
Well, and data is king in order to enable that. And I know this is a data conversation, and that's where if we optimize our utilization of the data, we can enable an AI decision-making loop that meets the requirement to defend North America.
Okay. So I know we are about 15 minutes from the top of the hour. I understand there's a lot of audience questions, so I'm going to let my colleague Dan Robitsky maybe bring up some of the questions for the panelists. Go ahead.
Hi, yeah, lots of audience questions. Thanks everyone for sending those over. Since you just brought it back to a discussion on the scale and scope of what Golden Dome could be, and you were talking earlier about needing to define the bounds of this project, Theo Bernard asked towards the beginning of our webinar whether it's conceivable to integrate the missile defense capabilities of allies, say from Europe or Asia, into Golden Dome, and if so, how?
Dan, do you want to take that?
All of
Yeah,
these are
I'll
for
jump
anyone.
on that.
Yeah.
I would say that yes, it's possible, and yes, we're doing that. There was a LinkedIn post that I'll try to get to you, Sandra, from an individual that talked about the integration of European capabilities that we're already using. And I apologize for not having the name, but I'll get that to you. But I would just say that that's something that we need to think about as we develop a system that, having that standoff and the sensors and shooters of our allies is something that we want to harness. And while we want this to be, a national system that protects North America, allies and partners, and that integration is going to be essential. I think we're doing that in many places, but we can continue to improve that. And much like the cross-domain solutions that we need to bake in, we need to bake in a system that can integrate different capabilities from our allies and partners.
I mean, maybe, but Dan, the executive order is called Golden Dome for America. So next question.
No, I
All right.
agree. But if we can use other people's stuff to protect America, we most certainly should.
Yeah, if we're not getting past the title, I suppose that settles it. We had a lot of questions about testing and training for these systems. I know you talked a lot about the AI models and the digital systems, but Josh Henley asks, lots of good discussion on what Golden Dome can and should be. Once that's established, what needs to be done differently in the physical realm to manufacture, test, and deploy these new systems? Adding that historic manufacturing and test timelines in aerospace and defense won't match the urgency outlined by the current administration. What can be done to overcome that challenge?
Rob, that would be a good one for you.
Yeah, I could take a first stab at it. So look, we just opened a new expanded and renovated facility in Indiana. We're about to open one in Florida. The one in Indiana is for our infrared payload center of excellence, and the one in Florida is Space Vehicle Integration Center of Excellence, about $250 million worth of company investment. And the key for us was to look at the space manufacturing challenge as a manufacturing challenge and to apply manufacturing techniques that had previously been applied in lots of other sectors, but never needed in space. We used to think we were the highest volume payload provider out of our Indiana facility. And we were about a payload and a half a year was huge volume for sort of our first 50 years, right? Operational systems for weather and other civil capabilities. This new factory drives us to a payload a week, right? So I'll have built more sensor subsystems between 21 and 26 than I did the first 60 years of our infrared existence, right? And I think it's very, very important to understand that it's the technology and the capability and the supply chain resiliency is building towards the moment where it is absolutely possible to do this, right? We have a paperless system. We have huge amounts of automation. We have a lean production flow. We understand how to get our what's called tack times to where they need to be. Our supply chain has built with us, right? Both tier 2 and tier 3 supply chain is working along with us to build their capacity that's been enabled by some of these proliferated constellations like Space Development Agency is driving, We're driving commercialized approaches. We're driving commercialized partners. We've delivered our both our prototype and our initial constellations in 3 years or less. That is a very huge step function change from where I would say exquisite space-based manufacturing was a few short years ago. And I think once you prime that pump and you're talking about, sort of one a week, then you're driving towards the speed and the capability and the quantities that an architecture like this requires. And I'm really, really bullish on our capability as an industry to really get there to the need, right? Really bullish on it. It's proven. We're showing it. We're ready for it. And so I'm really, pleased with our progress so far.
Great.
Dan, you have more questions?
Yes, I'm going to combine a couple questions here. There were a lot of people asking about the role that, quote, small industry could play, smaller companies, maybe newer companies, as well as the role that academia can play. So I'm curious for all of your thoughts on how there can be broader participation in Golden Dome in terms of developing and building it. Some particular concerns were the best use of academic facilities, as well as how smaller companies might be able to get access to the data needed to train the models you were talking about.
Pat, I think maybe you can talk about this. I know that Chris Bogdan from Booz Allen said that a lot of small businesses had reached out to Booz Allen because they wanted to be part of Golden Dome. So can you share any insights on that?
Yes. So a big focus for us, Sandra, has been partnering. You've read a lot about our venture capital fund, which was $100 million that we've recently tripled, which includes not only partnering with companies, but investing in early stage startups. I think a key to success for some of us that are bigger players is to have the right partners here, because the new partners and the new entrants, it's really hard to walk in the front door because they don't have the history of what is the problem we're trying to solve, how has it been done before, and even expertise in contracting and facility clearances, et cetera. So all of those things are really barriers to getting work done that the larger players can help in almost a mentor-protege relationship. So I do think I hope that the industry day encourages that kind of partnering and tries to break down some of those barriers, tries to set up a mentor-protege type status, tries to allow companies like ours that have a lot of classified contracts to start adding prospective partners onto those contracts to start getting people cleared. Otherwise, you're never going to get there in 3 years. That should start immediately. It should start last year. So I think that's a big focus. The second point I'll mention about academia, there are some opportunities for the universities and labs to directly participate. But one of the things that we need to think about, okay, I graduated with my PhD in 2008. And the global war on terror sucked up almost everybody that graduated with an aerospace degree that year. And that might happen with Golden Dome. Like if you have a high school senior that wants to be an engineer, they're probably working Golden Dome. They just don't know it yet. And so, yeah, that sounds a little bit like the militarization of academia. So I don't want to be all dystopian society, but I think we need to start talking to these university partners about how do we create a workforce in aerospace engineering, sensor development, system integration, AI, command and control, decision making. These are all things that if you employed every single person that exists today in the field, you probably still cannot meet the demand. So that is an aspect that is a long lead item that we need to start working immediately. Because by the way, the kids today that are playing video games will be the ones operating Golden Dome.
All right. Dan, we got a few minutes left. Can you bring up more questions?
Sure, yeah. I'll ask one more, and this is from an anonymous attendee, but earlier in the conversation, you were talking about C2 and the challenges facing that, as well as other capabilities. They were curious what other foundational technologies or capabilities we need to address in the near, mid, and far terms. You've talked a lot about how we have technology that needs to just be integrated, but I'm curious if there are any gaps that you can identify.
Yeah, I mean,
Dan-
oh, sorry. Go ahead, Dan.
no,
Yeah.
I'm sorry.
Yeah, so I'm not going to identify any explicit gaps that maybe we've observed, and we'll be shut down in like 2 minutes by someone who's watching this that will be upset. I think anytime we need an open system and a digitally engineered system that can evolve with adversary capabilities. 10 years ago, our adversaries did not have the ability to do a raid type situation like you've seen on TV. The advancement of hypersonics, the advancement of drones just in the last 2 years. I don't think 4 years ago we said, oh, I'm really going to be worried about drones in 2025. I don't think that was realistic. So what I would say is the gaps and seams are going to highlight themselves. Ideally, we'll identify some of those through, the model-based systems engineering and integrating the system of systems. But we need an architecture that allows us to evolve with the threats that we're going to encounter.
Rob, go ahead.
Yeah, I think I was going to focus on space-based intercept, right? That's a tough problem. There are certain aspects that are very straightforward, certain aspects that are certainly challenging. Our Aerojet Rocketdyne capability will come into the fray there. But certainly there's a significant amount of work required in sort of connecting sensor to shooter, in making sure that we can cover exo and endo atmospheric sort of threats, and be able to tie that system together with some of the things that Dan and Pat have talked about before. So I think the systems of systems challenge is as complex as we've been talking about for an hour, right? And the tool set for the industry is there. So I don't think it's an unachievable gap like it was in the 80s with SDI, where it was more aspirational. Today it is work for us to do to create that that integration of capabilities across our national capability into something that fits the bill for the architecture. So I think I'm optimistic about our chances of incrementally working our way there. And as Dan said, with evolving threats, it needs to be a resilient, flexible system that can stay ahead of it.
Rob, are you partnering with a lot of small businesses? Are you hearing from a lot of small businesses that want to partner with L3Harris?
Yes and yes. Yeah, and I think it's healthy for our industry to not think that any one of us can do everything, right? I can list off how we can do or contribute to every one of those 8 initiatives in the EO. It would be wrong for us to think that L3Harris is going to do Golden Dome. It would be right of us to think that us, in concert with the industry partners that both we pick and General Gutlein pick as part of his national team concept, are going to get it done.
Okay, so with that, we are at the end of the hour and the end of our discussion, unfortunately. Thank you for all your questions. A big thank to all our panelists for sharing their insights. Also, I would like to thank again our event sponsor, Amentum, for supporting this important conversation. And of course, thank you to all of you in the audience for joining us and participating and providing questions. So we look forward to continuing the dialogue, and everyone have a wonderful day.